እሺ አመሰግናለሁ ቤቲ። ዛሬ በእውነቱ ትልቅ ቀን ነው። የመጀመሪያው የቨርቹዋል ሴሽን የኤሮስፔስ ኢንጂነሪንግ ሌክቸር ኦፕን ሌክቸር የሚካሄድበት ነው። እንደሚታወቀው የኢትዮጵያን ስፔስ ሳይንስ ቴክኖሎጂ ኢንስቲትዩት በቅርቡ የተቋቋመ ወጣት ኢንስቲትዩት ሲሆን ከዚህ ውስጥ ከሰራቸው ስራዎች አንዱ የኤሮስፔስ ኢንጂነሪንግን ማጠናከር ነው። በቅርቡም የኤሮስፔስ ኢንጂነሪንግ ማስተርስ እና ፒኤችዲ ፕሮግራም ከአዲስ አበባ ሳይንስ እና ቴክኖሎጂ ዩኒቨርሲቲ ጋር በመተባበር ላውንች ተደርጓል። ይህም በአገራችን ለመጀመሪያው የኤሮስፔስ ኢንጂነሪንግ ዘርፍ የሚሰጥ ተቋም አድርጎታል። ይህንኑ በማስመልከት በየካቲት ወር ለአንድ ወር የሚቆይ የቨርቹዋል ሴሽን ስለ ኤሮስፔስ ኢንጂነሪንግ አስመልክቶ ውጪ ከሚገኙ ኢትዮጵያን ባለሙያዎች ጋር በሀገር ውስጥ ላሉ እንዲሁም በተለያየ ቦታ ሆነው እድሉን ያላገኙ ግንዛቤ እንዲኖራቸው መሰረታዊ እውቀት ክህሎት እንዲኖራቸው ለማስቻል በማሰብ የተዘጋጀ ፕሮግራም ነው። ይሄንንም ያዘጋጁትን የኤሮስፔስ ኢንጂነሪንግ ዴቨሎፕመንት ዲፓርትመንት አባላት ማመስገን እንፈልጋለን። እንዲሁም ጊዜያቸውን ሰውተው በበጎ ፈቃደኝነት ያላቸውን እውቀት ሼር ለማድረግ አብረውን የተገኙትን ባለሙያዎች ለማመስገን እወዳለሁ። በተለይ ዛሬ የሚያቀርበው ዶክተር ጆሴፍ ሽፈራው አይ ቲንክ አይ ኖ ሂም ለረጅም ጊዜ አውቀዋለሁ። በዚህ ጊዜም መጥቶ እውቀቱን ሊያካፍለን ጊዜውን ሰውቶ ስለመጣ እያመሰገንኩ ይሄ ልምድ ወደፊት እንዲቀጥልና ለወደፊቱ ደግሞ ቨርቹዋልም ሳይሆን በአካልም ይሄን ነገር የምናደርግበት መደላድል እንደሚፈጠር ተስፋ አደርጋለሁ። ስለነበረን ጊዜ አመሰግናለሁ። የተሳካ የቨርቹዋል ትሬኒንግ እንደሚሆን አምናለሁ። አመሰግናለሁ።
እሺ አመሰግናለሁ አቶ አለምዬ። በመቀጠል ዶክተር ጆሴፍን ሌክቸሩን እንዲጀምሩ ሄሎ
ይሰማል?
አዎ ይሰማል።
መልካም ኦኬ። ስለዚህ እንግዲህ እንትን ቤት ነው ያለውኝ። አንዳንድ ጊዜ ባክግራውንድ ጫጫታ ካለ ለዛ ይቅርታ ጠይቃለሁኝ። አቶ አለምዬ በደንብ በአካል እንተዋውቃለን። በእርግጥ ብዙ ጊዜ ሆኖናል ከተገናኘን። የሆነ ሆኖ ግን ያው አልፎ አልፎ እከታተላለሁ የምታደርጉትን ትላልቅ ነገሮች እና ለዛ ትልቅ ምስጋና አቀርባለሁ። ወደ ስክሪን ሼሪንጉ ሄዳለሁ። ምናልባት ስክሪን ሼሪንጉን የምታሳውቅኝ ቤቲ ትሆኛለች በደንብ የማይታይ ከሆነ። ስለዚህ ወደ ስክሪን ሼሪንግ ሄዳለሁ። የሚታይ ከሆነ ትነግሪኛለች። አሁን ያረኩት እንትን አለ።
እሺ
ኦኬ። ስለዚህ ወደ ፕሬዘንቴሽኑ ሄዳለሁ።
ይታያል።
ኦኬ ይታያል አይደል አሁን?
አዎ።
ኦኬ ሁሉም ኢትዮጵያኖች ይመስሉኛል ያሉትና አስፈላጊ ከሆነ ሁለቱንም እንግሊዝኛንም የአማርኛንም ቋንቋ አደባልቀን መጠቀም እንችላለን። በስፔሻል የሆነ እንትን ከሆነ የስቴጅ በእንግሊዝኛ ማቅረብ እችላለሁ እና አማራጭ ያለው ነገር ነው።
አይ ቲንክ ኮምፎርታብል በሆኑበት ማቅረብ ይችላሉ።
ዌል በቃ እንግዲህ በሁለቱም እሄድበታለሁኝ። ለመጀመሪያ ያህል ይሄ የመጀመሪያው ቤዚክ የወርክሾፕ ማለት እንችላለን። ብዙ ቀጣይ ስራዎችን አብረን የምንሰራበት ነው። አሁን ለጊዜው ግን ኦፕን ሶርስ ሶፍትዌሮችን ለኢትዮጵያ ላሉ ጓደኞቻችን ማሳወቅና አብሮ ለወደፊት ሪሰርች መስራትን በተመለከተ ስለሆነ የኔ ፕሬዘንቴሽን የሚለው የኤርክራፍት ሞዴሊንግ ኤንድ ሲሙሌሽን ሶፍትዌር ቱልስ ነው። They are mainly of open source type, but I will give an introduction on some sort of commercially available softwares and also free student version softwares like ANSYS, CATIA, and others. So እነዚህን ሄድበታለሁኝ። ፕሮባብሊ የኔ ስም ጆሴፍ ሽፈራው ጆሴፍ ቤት የሚጠሩኝበት ስም ነው። ለትክክለኛ ስሜ ግን በአካደሚክ ኤሪያ ላይ በአያት ስም ቱሉ ወይንም በራሴ ስም አበራ በሚል ነው እዚህ የሚያውቁኝ። በአብዛኛው በቱሉ ነው የሚያውቁኝ፣ ግን ቤት ውስጥ ጆሴፍ ሽፈራው ወይንም ጆሴፍ በሚል ስም እጠራለሁ። ኤኒዌይ ወደ እንትኑ ልሂድና በአራት ዊክ የተከፈለ ነው ይሄ። And the first week we'll talk about aircraft modeling and simulation tools. And as I said, there are open source softwares and also commercially available ones. In the second week, we'll talk about the flight control software, or you can call it firmware, where actually firmware is for those software developed by the low-level language like C, or like driver softwares and system control softwares, what we have there. They are actually called firmwares. This is a special case, but normally we can call it software. But the majority knows that software is the application feature that we add to the firmware for our own purpose. So the other one is on the week 3 and 4, where this is dedicated to the software in the loop simulation, using those software flight control softwares. And also we'll have other features that the 3D simulation environment that we will integrate into the flight control software. And also we have other features like robot operating system that we need to add into it because of some features we need, the libraries we need from this robot operating system. So in the first week, we'll talk about the Open VSP, which is the vehicle sketchpad. This stands for vehicle sketchpad. It's open. That's why you call it Open VSP. This software is released by NASA for public domain, so anyone can use it without any cost. And the second one is about CATIA and Blender. As you know, CATIA and Blender are very famous for design. So in our case, what we are using in our laboratory is CATIA for interior design of any vehicle. For exterior design, OpenVSP is there, and also there is some modules added to OpenVSP for aerodynamic analysis. So mainly we use CATIA for interior design or OpenVSP for exterior design. The other one is ANSYS Flown. This is advanced level CFD for high fidelity simulations. But OpenVSP is just for preliminary and conceptual level of design. So we'll talk about that in depth. The other one is week 2. As I said, we have a flight control firmware that we focus on. The open source type, like a PICSOC. Normally the software is called the PX4 or ArduPilot. And actually there are other more, but the widely used softwares are PX4 and ArduPilot that I can present to you. But I will go over like briefly the difference between the two firmwares. And then I will focus more on the PX4 firmware type, which is a very known flight control software that we use for drones. Not only for drones, actually, we use it for marine vehicles, for ground vehicles, or any other robotic types. Nowadays, people are using this PX4 for firmware. And the last 3 weeks, I mean, the 3 and 4 weeks are for the software in the loop simulation, where we use the PX4 flight control firmware to do everything, every algorithm test on the computer-based loop. So we don't need any flight control board like PICSOC. We just do everything on computer. That's why we call it a software in the loop. We don't need the hardware. And we'll see that in depth with the simulation environment called Gazebo, which is a powerful 3D simulation environment. PX4 is already integrated to Gazebo, so you don't need a lot of work to do things. If you want to do the simulation of any vehicle model in this 3D simulation environment. The other one is the integration of PX4 Gazebo and Robot Operating System ROS. If you need more advanced features like object tracking, detection, obstacle avoidance, and so on and so on, the best way you can do is you have your own companion computer, which is integrated to the PICSOC flight control board, and so that the companion computer will handle the image processing stuffs where the PICSOC is dedicated to the flight control type. So we'll talk about that in detail, but for today, as I said, our focus is on OpenVSP. It stands for the vehicle sketch pad or sketching pad. This is normally released for free for public use by NASA, and still is under development indeed. Many people are contributing to this software. The other thing that is integrated to VSP is the VSP Aero. The VSP Aero is to analyze the aerodynamic performance, control, stability of the vehicle you designed. And after you did that, you directly go to the interior design using CATIA and Blender. If you need some interior design, of course, most of the time, once you are satisfied with the aerodynamic performance and control, stability is okay, you have to do the interior design, and then you bring it back to the VSP Aero or ANSYS for final analysis. So ANSYS is there. ANSYS is commercially available, very expensive, but still you can use the student version for limited access. So I may show you how to export any vehicle you designed in OpenVSP into ANSYS and also into CATIA and Blender. Indeed, ANSYS is not allowed, so I will just show you how to export the file format you need to export to ANSYS from OpenVSP. So with that, I'll go to the demonstration part. So I hope everybody has to focus mainly on what I'm doing right now. Up to now is just a basic introduction. So I'm going to bring the OpenVSP from internet. Then I will show you how to download it. It's free. You just type it OpenVSP, and you'll see directly there and then on the internet, and you can download it if you want. Actually, I already downloaded. There are different versions for Windows, for Mac, and Ubuntu, but the best one is for the Windows versions that we mostly use. I sometimes use Ubuntu because most of my works related to PICSOC or PX4 is on Ubuntu. So the best way is to go with the Windows version. So I'm not going to download it. It's already downloaded for me, but you can do it by yourself. And I am going to launch the downloaded OpenVSP from my computer. So I'm going to go into this. So yeah, right here. I have different versions. That's why I'm confused. Okay, I'm going down. Pay attention here that we need to launch this one, not VSP Aero or something else, just VSP. Click on it. If you want, you can launch it using the administrative type for privilege, but doesn't matter. So you get the impediment. Wait.
Screen sharing got afterwards. Now, could you turn it on?
Okay. I will do it again.
Okay. Thank you.
Okay. All right. So yeah, I was here. I guess I'm here. Can you see it now?
Yes.
Hello?
Yes.
All right. Okay. Okay. Shall I launch it again? Let me launch it again for you. Okay. Or I can just show you where I can launch it from. I will launch it from the folder VSP is there. You just right click and launch it with the administrative privilege. So then you get this empty window. If you have already designed model, you can just open it from the open. and I do have plenty of that down there, but for today I'm going to start from the scratch. But before I go into the modeling, I want to say a bit about the tabs we have here. We have the file. Actually, you have everything you can import. You can save the file and also export your results to other like CATIA and ANSYS. And also you have in the window, or you have the background. It is very important that you know this, because you will bring a background. For instance, the already modeled aircraft 3D views can be imported. I mean, the 3D directions of the already modeled aircraft can be imported into the background, so that you can use that background to sketch your own vehicle, quite similar to the background you have. So this is important. We'll talk about that later. In the view, you have different views of the vehicle you design. We'll see it also. And the model also, you have different options like geometry. You'll see what geometry is. You have the design variables, especially for those who are in need of doing some optimization. So there are some design variables that you can list out here. Those design variables will be integrated to the optimizing algorithm, so that it can cyclically optimize the variables as you want. And I'm not going to talk about the optimization of the aircraft wing or anything, but just want to highlight that. And the most important one is here. Here you can see the mass, the inertial property of the designed vehicle. And most of all, you'll use this module, which is VSP Aero, which is for the aerodynamic analysis of your model. So with that, let me go into, actually you have a lot of options, tabs here also, if you want, and you can see what they will do. But how do you add the vehicle model? The vehicle model is it's not exactly the model, but the components are already there. I'm going to show you that. For some reason, I can't drag it down. Oh, I'm sorry. Oh. Okay. Is it okay? Can you see it now? Okay.
Yeah, we can see the screen.
All right, thank you. So here you have plenty of components you want, like the fuselage, the wing, and some stack blank, blah, blah is there. The propellers, if you want, is there. And the discs and different types, like a box group to add inside the vehicle, so that it will represent some interior objects, mostly for weight analysis. You can add those components like boxes and different types of ducts for the engine part, and also you can add seat and podman and so on and so on. But mostly what I use is the fuselage and the wing, and the wing can do everything you want. So let me go with the wing, and then we'll see the rest. Click on the wing and then click add, so you get the wide version, or the wide view of the wing section only. Now you can click on the shade here. You see, if you see it, the shade. Oh, let me drag this thing down. If you see the shades, it will give you the shaded version of the wing. Or you can call it, this is like a blended wing body type of aircraft. So now there are different terminologies you may see here, different terminologies. I will talk about that. We have airfoil, first of all, the airfoil at the center, and the other airfoil at the tip, airfoil. And I'm not sure whether you guys have got the basic terminologies of all the aerodynamic components, like airfoil, ribs, span, and cord, and so on and so on. So if not, just stop me somewhere and then ask me what it is if you want. So now we have this thing. If you want to modify, no, before I go into that, the wing span is from this tip the distance from this tip, the lower tip to the upper tip if you want. And you have the length, which is right from here up to the end. And that is actually the chord length of the airfoil, the central airfoil. So you can modify this, but if you want to see the length of your wingspan, you just go into the plan, click on the plan, you see the span. This is the total span you have. By the way, I didn't tell you that OpenVSP doesn't have a specific unit for you. You can assign yourself whatever unit you want. Like if you want to go with the centimeter, this is like 18 centimeters. So you can do with that, or maybe you can go with feet, inch, whatever you want. But you have to keep the consistency of the unit when you do for the rest as once you decide in your mind. And the other thing, as I said, the OpenVSP is for vehicles that has the maximum speed of Mach 1, which is not more than the subsonic level. If you go more than subsonic, the solvers you use for aerodynamic analysis of the vehicle doesn't work well. There are so many assumptions you have. That's why this OpenVSP is limited only for the preliminary and conceptual phase of any vehicle design. So, so you got the span here. Let's say this is 18 meters. So keep in mind that we are working with meter, and you have a the projection span, which is the shadow of this span on the ground, which may be not the same as the span of the aircraft itself if there is some dihedral type of shape. And so you have a chord, which is the mean chord in this case. The mean chord, this is the average of all the chords. You have the chord lengths of the central airfoil, the chord lengths of the tips and the tips, and so you get the average of that. That is the mean chord. So now you can drag this one if you want. Like if I want to modify this one, I just go to the airfoil because this is airfoil. Now airfoil 0 is for the central part. So I can drag this. I'm sorry, I have to go to the section part because I have to increase the length, it's not the thickness. So the section, normally the section is what you see in green is one section. If you have a split of that, let's say I have a split now. So we have 2 sections now. So click on the wing back. By the way, you can rename it also. You can call it whatever you want, BWB. You can call it, and if you leave it, you will name it. So you have a section right here. Now I want to extend the central airfoil length. Go to the section, and this is the section now we are talking. The section has now this is the section platform. You can see here section platform. You can increase the span. The span means the length of the section itself. So you can increase it if you want. Or if you want, also you can increase the airfoil. There are 2 airfoils of the section, the external and the internal airfoil. The external one is which one? It's just an outside of the central part. So this is the central here. Now let's do some tricky things. I mean, that's not tricky, but like you can modify the length of the airfoil right here. You have a root chord and you have a tip chord. The root chord is for the central part. Always toward the center is the root. So you can right click, I mean drag the chord. So you can increase it as you want. And also you can do for the tip also. The tip by now is this one. It's not that one because we are talking about the section. You can also drag that as you want. And if you want to increase, and by the way, I can show you this is the symmetric, so I can cut it into half. So I can show you only one wing because everything you did for this wing applies for the other wing. So you have symmetry, right? If you click on the second tab, you have a symmetry here. This one, you can click the symmetry, you can see it. You can avoid it, whatever you want. So, but anyway, if you want to see from the side, it's better to have a single wing, one side of the wing. So now let me by the way, there are some tabs that you need to click to view your vehicle from different direction. In the view, you can see here mostly the F5, which will give you the top view, and F6 that will give you the front view. You can go through this. This is the F7 side view and so on and so on. So I'm going to go with the with the F7, the side view. Now I'm going to, this is symmetric type of airfoil, and usually this type of airfoil is at the tip of the aircraft because it doesn't produce any lift at a zero angle of attack. So we normally use that at the tip to avoid some turbulent flows of air on the tip side. So I can go to the airfoil now. I can increase the thickness of the airfoil. Like you see here, the airfoil. I can increase the thickness of this airfoil as I want. You can drag it, or you can give the number here. Remind you here that we have no unit specific, but keep in mind that you are doing with a certain unique unit in your mind. So the other thing is, there is no camber for this. It's symmetric. You can add the camber. You can bend it as much as you want. And you can also decide the camber location, the maximum thickness location. You can drag this one. The maximum thickness will move back. If you see, it will move back. And so this actually depends on what you want to do, in which area of the wing you are applying this airfoil. And also you have options to select from the option listed here, the type. You can choose from this whatever type of airfoil you want. And so it's up to you. And also you can see this line view of the airfoil you are doing with. And if you change the thickness, you will see the change also right here. Especially if you don't have this view, you can directly view it right from the show. And so you can do that. And the other thing is, let me bring it back. There are some tabs that I don't use, like converter tab. It inverts actually. There's an invert airfoil also here, but I don't know what they are using that for. If you click here, you can design. You can give each point of the airfoil by yourself, and you can modify it as you want. Especially if you are doing this blended wing body type of aircraft, you have to design the interior part by yourself manually because of your own special interest. The central part is not basically for aerodynamic lift. You have to primarily look into what you will have in the interior part, what components you have. So you have to determine whether the thickness of the central airfoil and the subsequent ones close to the central should be enough or not for the objects you want to load inside the aircraft. So that is one thing you see here. So you can select different types as you want. The best thing about this OpenVSV is that you can see the changes right away. It's a parametric type. You can just give the number or drag the score, and then you get the shapes you want. Now, what else I have to see here? There is this actually is to move your section or the wing itself to either X, Y, or Z, or you can rotate it. Now, if you drag this one, you're moving the wing back, especially if you have airfoil. Let me add, the fuselage. Let me add the fuselage and see how we can do that. Let me go to the shade. Now the shade, so I can move the wing backward. So I'll click on the wing part and drag it backward. If it's like at the end, it's not end actually. You can click on the arrow and then you get more. You can move it more back. There's no problem in that. And also you can increase the size, as I said, and you can bring back the symmetry. And now this, if you see, like I can do this. Like I can hide this one. You can hide this one if you want. No show. You just click on no show, so you can see here. And now I want to move the wings apart because there is a fuselage there. So click on the wing and go into this X form, and then if you drag this one, the wing will move apart. Now bring the fuselage back. You can see it now show. So you can see it now. You can move the wing as you want. By the way, the OpenVSP is not only for aircraft, for any like rocket design, for ground robots, like underground, like I mean the underwater type of vehicles. For anything you want, you can design right here in OpenVSP. I mean, for the design part at least. The aero part is not such important. Now, I can cancel the fuselage. I don't want it now. For now, I'm going to deal with the wing. So bring back the wings together. This is a blended wing body type. Now, we did that. And also, if you want, you can change the colors right here. You can go into color and change whatever color you want from the drop down right here. But it's not that such important. And also, indeed, if you have different components that you want to visualize, yes, indeed, you need to have different colors. So that's it. As I said, the section is there. One thing I have to talk about section. Actually, it's not one thing more. Now we are dealing with this section. I think this is not visible. Let me change that into the default one. Well, yes. Now, the top view. Top view, and one thing I did here is it has to come to the origin. You can drag it. You can zoom in and zoom out. If you hold the scroll the button of your mouse, you can bring it out and in. And also, you can do any other things with the right click and left click. The right click is actually to move it. I mean, yeah, move around. And then the other one is to rotate. The left click is to rotate, and then you can exercise this. Now let me go to the section part. Now I'm talking about this section, and let me give the front view. The front view of the vehicle is like this. I want to give some sort of dihedral, which means I want to bend it a bit up. So you go into the dihedral and give it like, say, 20-degree dihedral. Now this is too much indeed. The 20-degree dihedral is too much. The importance of this dihedral is like if you want to make enough lift during roll, you have to design the vehicle in such a way that the wing somehow bends upward, so that when it rolls still, say for example, if it rolls to the left, as I show you, if you have a bended wing right here, still you have some lift generated by this wing side. So the dihedral type is very important. It actually depends on the type of mission the aircraft is designed for. The dihedral is there, and also let me go into the so we did this. The dihedral is there. Also, you can twist the wing, especially the outward wings. This wing at the end of the wing or the tip area, you have to twist it somehow upward from the back, from the trailing edge upward, because if the aircraft is to stall, Normally you have the control surfaces like aileron on this tip. If the aircraft is to stall, it has to stall in the interior part first. And if you twist it up, even though the aircraft stalls in the interior, this surface still generates the wing. There is an airflow on this surface. If there is airflow, then the control surface like aileron will bring the aircraft back to normal. So normally they do twist for that reason. And let me show you how we twist it. Let me just give you the front view. And I'm going to twist this one with say exaggerated 40-degree twist. This is twist down, and it's not as such important. We have to twist it up. So this is exaggerated indeed. So as I said, if the say the angle of attack is very high, the aircraft stalls because there is no enough lift generated by the aircraft surfaces over the central part. As you can see here on the tip, there is still the surface which is touched by the wings, which is called also the wet surface for now. The wet surface is the surface on which the wind flows. So at least you can have the control of the aircraft by the ailerons you have at this area at the tip. So that's why they make a twist. Anyway, we'll bring it back to normal. We don't need it now. The other thing is you can go to the blending. Blending is normally to smooth the leading edge areas and the trailing edge areas. That is like, for example, if I have, let me add more section, click on section. Let me add more sections into the aircraft. Now split it in. And so let's say this tip is rotated. I mean, the tip is shifted back. That is it. I'm sorry. That should have been a sweep back. I'm sorry. So if you want to get back, you just click on the undo, edit undo. You can get back to the original shape you have. So let me sweep it back. If you sweep, you give more angle of sweep. Say okay, like 50. I do the 50 now. As you can see, the edge is not smooth here. The edge is not smooth here. If you want to smooth it, and also it's not smooth here. If you want to smooth it, and if you are satisfied with this shape and you want to smooth it, and you go to the blend, and so the leading edge, and also there is a trailing edge. The leading edge of the aircraft at this edge, and the trailing edge is there. So you can smooth, for instance, this cornered section. You just click, I mean, let me go into the leading edge and say the outboard, the outboarding. Let me click on the, say you have options indeed. You can use angle to make smooth leading edge. Say for example, an angle of 40 may not that much smooth, but somehow it tries to smooth it. And if you add, if it reduce down this to 20, you will see that more smoothed shape is there. So you can use angle, or you can go into the outward leading edge. The outward is from the central into the tip always. Now we are here on this airfoil. The outward is this one. So you go into the outward leading edge. This is the trailing edge, so we don't do it now. Leading edge. So you can go and add the strings if you want to the leading edge. You can add the strings, but that string is not enough. I can't see that much of differences indeed. Okay, we will see in the others. Probably if I go into the other airfoil here, and let's say this has to follow the inner leading edge, which means the inner one is this one. So whatever you have in the outer part of the airfoil has to follow the inner one. So you can have that type of smoothing like that. So you see the effect of So you can increase the strength, but normally that will mess up everything if you want. So we have this thing, and if you want to scale any airfoil, just scaling, like click on here to modify on here, click modify. You have actually shift, rotate, scale. Shifting means you can shift backward, like for example, let me go with one of the airfoil like here. Okay, now you see the blue line that shows the active airfoil we are working on. So you can scale it if you want. You just go into the scaling and let's say 1.5 and see what will happen. Like what will happen, as you can see, it will scale in every direction. The thickness also, not only it's not only the tip of the aircraft, which actually is designed for a specific purpose, like reducing some turbulences on the. Okay, now with that, you can go through everything: the leading edge, the trailing edge. You can modify, and also there is, as I said, the blending for trailing and the leading edge. And we have different type of airfoil selection, and also you can add your own airfoil if you want. So that is, you can click on here, and I guess this is on air file. Click on here, and so you have to click like read. You have to bring the airfoil that you have from your own source. So actually this are enough, and there's no specific need to bring airfoils unless otherwise we design a special type of aircraft. So this is this type. Oh, I can get back to your original shape. Now we have, I think, is there any question? Please, if you have a question, you can raise before I go ahead. Any question? I'm going to go to how to create the control surface aileron of the UAV or aircraft. So if you don't have any question, let me go to the control surface. If you see here, there is a SUV sub. That's a subsurface. You can click on it, and so you can click on here. Right here. It says control surface. Don't go with the line, rectangle, and so on. You just go with the control surface because we're going to do the control surface design. Click on it and then click add. And now see that the ailerons are right here, but you can shift them. You can shift them span wise. You can shift it like this, and also that move that one to the tip. Move it, and also you can increase the area of the control surface depending on the control and stability of the aircraft. Or normally that's what you have in your mind. And also sometimes after you do some aerodynamic analysis, you'll see that the control surface assigned is not enough to control the aircraft, so you have to add a bit of the surface by clicking on the chordwise direction. The chordwise direction will give you, this is like only 25% of the chord length is used for control surface. You can add that if you want, like this. You can add that using this. The other thing is we'll talk about the how we can put the angle of the ailerons in the aero VSP aero. Now I have to go into the simulation after we do this aircraft design, and we satisfied ourselves that it's okay. And then I will go ahead with the VSP Aero, the aerodynamic analysis of the vehicle. Now go into the analysis, click on the analysis. This is the third-party module which is integrated to VSP. So VSP Aero is very powerful, at least for the preliminary and conceptual phase of the design. So click on it. If you click on it, the VSP Aero gives you an overview. What you see over here, the vortex lattice. This is the solver. This is the one that solves the pressure distribution on the surface of the aircraft. And also there is another solver called the panel method. You can read about the vortex lattice and the panel method of design approach. I mean, solving approach for pressure difference on the surface. Normally, what it does is any of them, you have to have the meshed surface of the aircraft. There is a geometry measure. If you go here, I'm sorry. If you go here, the CFD mesh, FEA mesh, and degenerate geometry mesh is for vortex lattice. Normally, people use this one, the vortex lattice, rather than the panel method. The solvers are there for you. You can read about that, and you can go with whatever you like. And here you see that it's the word says show, which means in this case, if you click on show, you have different type: all, show, not show. Show means you do the aerodynamic analysis only for the shown part of the aircraft. You can hide some component of the aircraft. For example, I can add the fuselage, and the fuselage is there, but I will go into the fuselage and say hide or not show, and then I'll go click on here and go into the analysis of VSP Aero, and then here you see show. It is to mean only for the wing or BWB part, not the fuselage. If you want to add the fuselage, also you click on all. Not show is only for the fuselage, not for the wing or the BWB. So I will click show. And also you have the CG, the center of gravity of the aircraft, can be calculated. If you click on here, you can get the center of gravity, the X location, the Y location, and Z location of the CG of the aircraft. And later on, we'll see that. And also again, you can calculate center of gravity only for the shown part or for all. You can do that. Now, by the way, you can see the inertial and the mass property of this thing. If you go into the mass probe, you right click analysis and then go to the mass probe, and you can do slices to get a distribution, inertial distribution. Now you see here there is a mass and there is a the inertial property of the vehicle design. I mean, given here, but now you can compute. If you click on compute, you'll get the computed part of variables of your drone. I mean your vehicle. So the mass is whatever you use, 19 kilogram probably. And also you have to go with the second and so on and so on. You have to go with that, and like the CGs, I mean the MEKs. Now the inertial property is also there. Now you get this one. Don't be panic. You can cancel this one. This is just the meshed or the partitioned part of the aircraft to get the calculation for the mass and inertial distribution. So you can click. It's right here. You can click and delete it. You don't want it. That means now it says the BW is not shown, but you can click on it and then click show, so you get back what you want. Okay, now let's go with the aerodynamic analysis. Okay, now let me go into the answers analysis and the VSP. As I said, I have everything in here. There's also alpha here, which is an angle of attack for calculate the aerodynamic performance of the vehicle for different angle of attack. Let's say I will start from -5, which is a nose down, and up to 15, and do like say for example 10 times. Now beta is the side and for now, let's see, we just consider only the aircraft, the airflow in the direction of opposite to the direction of flight of the UAV. So the other thing is the Mach. You can calculate the Mach number based on the maximum velocity of the vehicle you want. Normally, you have to come to this design after you do some analysis on the wing load and the way to thrust ratios and so on and so on. You have to have a criteria for designing this vehicle. Those criteria are like the maximum speed, the turning angle, and so on and so on. So you bring the maximum speed you have, and you can calculate that if you want. This is in Mach, which is the speed of the aircraft divided by the speed of sound, which is about 340 meters per second. You can calculate, and let me just do for now about 0.05, which is around 18 meters per second, 1/8. So I would say this is a Mach, and let me go into the design, and everything is there. So this is the surface you have, and this is the span, and this is these are actually mean. This is the chord length. This is not calculated yet, but this is just given as a references. But you don't have to worry about that. It's already managed by the software itself. So now we have that, and we are going to do. We are not going to do the advanced one now. Because we'll see later what they have, the control surface and so on and so on. But overview, just click on the overview. And now for now, we did the angle of attack is known, and we have at least 10 outputs in the range of -5 to 15. And I'm going to launch the solver. For now, the solver is Vortex Lattice, but if you want, you can click on this one. But the best one I have seen is the Vortex Lattice for me. So, okay, I'm clicking on the launch solver. So the solver will take a bit, no more than like, yeah, it's very, very fast, because the reason why you get the solver the result very soon is that because the sections we have are very few. So the shape is not so complicated. This is a blended wing body. There is no open surfaces. Everything is watertight. So no problem, the solver can do it in a minute, so in a seconds. So that is one of the things. After you are satisfied with the output of the results, you have to give more sections or tessellations. I will show you the tessellations into the aircraft, so that you will get the more smoother surface of the aircraft, and you will do the aerodynamic analysis, and you get more refined values. So for now we have this, and this one shows you the wingspan, the lift distribution along the wingspan. When I say the wingspan, I mean the wing distribution, the lift distribution on the surface from one tip to the other. So you have the negative 8, -8 to 8, which is one tip from the wing is at -8 or whatever unit we need, and the other end is that one, the 8 meter, probably 8 meter or not. I'm not sure. Whatever you need to use, you can use it. Just a minute. I want to fix something. Okay. Now you see there are some problems around here. The airflow is not smooth. The lift is not uniformly distributed on the surface. So you know exactly where it is. It's around 0, which means around the central part. It's because of, you can see right from here that there is some curvatures over there, the lift distribution, and some drags, interferences, and so on and so on will affect the lift distribution over there. So you have to go back and redesign the surface there to get the smooth distribution. And so the other important thing you have, this is the load distribution, on the surface. Now this is good. Most of the load is distributed around the center where the airframe of the aircraft is more stronger. Around the tip, if we get the highly picked up lift distribution, you have to be careful on that, because otherwise the structural integrity of the vehicle will be in is not in a good condition if you fly it. Sometimes you may get the aircraft flown apart up in the air. So you have to be careful on that. And this happened sometimes in the past to some of our friends. So it's actually, this is a homemade type of UAV, so it doesn't have any effect. Okay, then you can see here you have distribution for different angles. This is for -5, and the others are intermediate, and this is for 15-degree angle of attack. So for 15-degree angle of attack, you have high lift distribution, but the roughness of the distribution around the central part increases as you increase the angle of attack. Now, the other thing very important is going to here, the sweep, and going to the alpha, the angle of attack, and then going to the pitch movement. The pitch movement. This is very important. Now we have on the horizontal the angle of attack, and the vertical you have the movement, the pitching, the nose down and nose up of the aircraft. Now what we see here is as the angle of attack increases, the pitch movement gets lower and lower and lower, which means the slope is negative, which means the aircraft is trying to nose down as you increase the angle of attack, which means the aircraft is more stable now, at least statically stable, because it tries to return back to the level flight. Otherwise, if you get the positive slope of the aircraft, you have to somehow move the center of gravity, or you have to sweep back some sections and recheck the tendency of the pitch movement of the aircraft. For now, it's okay. But if your aircraft is mostly for a long flight, mostly it's like a level flight, so you have to see at a 0 angle of attack, what is the tendency? It's almost 0, right? Wow, this is very important then. And so the aircraft will not pitch down or pitch up. So it looks like it's a fuel efficient type of aircraft in this case. This is just fortunate. But anyway, the design is not that much interesting. But anyway, okay, now what is interesting is that we get the negative slope, which is very important. So we can say that the aircraft is stable. And so you can do the other things. You can compare alpha with the drag if you want. The drag increases as angle of attack increases. This is obvious. And also you have this is a side forces, like the force from the side on the aircraft. We don't have that much of forces. The moment, this is moment about X, which is a roll. The roll tendency, it doesn't give sense now. This is for the yaw. Oh no, so this is for the pitch, this is for the yaw. So there is no yaw, which means the aircraft is flying straight forward, which is not true. But anyway, we are interested in the pitch moment, which is very important. But for advanced type of design in DDS, you have to consider everything you have here. So the other thing is now we see that, for example, we see that in here, the pitch, the level flight at zero angle of attack, the pitch moment is 0. What is the lift to drag ratio at this point? Now we'll go down. The lift to drag ratio at 0, angle of attack. Click on here. The lift to drag ratio is about is 0, which means now the aircraft is balanced. The lift and drag at the same. I mean, close to 0, which is very small lift, which is not important actually. You have to have a positive lift to drag ratio, at least at the level flight, for that matter. So the dots are just around the sections, the calculation made around the sections. You can add more sections so that you will fill out this thing, and it should not be like a curvy, I mean, the edge type of this. You will get a smooth line if you add more refined sections into it. Anyway, this doesn't give sense. It should be like a positive type of lift to drag ratio. Anyway, where do you get the maximum lift to drag ratio? It is at an angle of, say, around, it looks like around 1.6, around 1.6, around 1 point something, around 1 point something, not 1.6, or 1.22, 1.1. So, which means if you fly your aircraft at an angle of attack of 1.2 degree, and so you will get the fuel efficient flight. The lift to drag ratio is very, very high. So there is huge amount of lift and or less amount of drag on the aircraft. So those are the criteria. You see, you have to go in detail on all of them. And once you do this, let's go. Oh, sorry, I forgot to tell you the other part of this. Click on it. Yeah, it's already there. Okay, now there is another one. The result you get now is from here. Whatever we see here is from the result manager. There is another one, the launch viewer. You want to see the pressure distribution on the surface. Click on here. It's right here. Click on it and maximize it. Go to the legend. You will see now the pressure distribution. I'm going to show you the pressure distribution. Before that, but I want to show you where the center of gravity is. Draw the center of gravity. You see the red dot right there. That shows you where the center of gravity is. Now, with respect to this center of gravity, where does the lift distribution is high? Is that at the back or the front? And those things are very important. So, and also you can get the number if you want. Oh, I'm sorry, there's something wrong going on here. Is that from you or what? Hello, can you hear me? Any problem? I have to go ahead anyway. So I will go into
you can proceed.
All right, thank you. So I have to go to the arrow pressure distribution. Now you see the most of now, by the way, this is the pressure differences, the lower pressure minus the upper pressure. You have these pressure differences. Now the blue ones are high pressure differences, positive pressure difference, which means the pressure on the lower surface is higher than the upper surface, which means you have more lifts around here. And there are some low pressure differences here, which is, I mean, negative pressure differences around here. Oh, I'm sorry, I said in the reverse way. In the reverse way, the pressure difference is upper minus lower. So you have here the upper minus lower. Around here, the upper is very low as compared to it's around 0.000, almost close to the lower. In this case, we don't have enough lift, as you can see. This is, by the way, just a surface, because it's not important to show the 3D view of this. Around here is almost for the drag. It's almost for the drag. By the way, we are considering this for negative angle of attack -5. For the other angles, you can see how the drift distribution changes. You can click and see for all of them. Okay, anyway, let me get back to say 0 angle of attack. Around here. Okay, we have that 0 angle of attack. Now, most of the lifts are at the back. The CGs are here. So it depends what type of aircraft you want. Where the CG is close to the average aerodynamic center, or away from the average, from the CG. If the aerodynamic center is close to the CG, then you will get the more stable aircraft. So it is sometimes hard to roll or pitch the aircraft from a stable level flight. If it is close to 0, it is more like maneuverable, like acrobatic type. If it is far away, it's more stable. So that is the type of aircraft you design matters. What I want to show you here is that you can check how the pressure is distributed on this surface. Okay, so we did that for different type of angles. Now, one thing I want to show you is that the legend part, the pressure, and you have from the trailing wings, how the air flows. You can see from the front, the air flows for almost 0 degree. This is for -5. You go ahead and see how the airflow is changing direction. So it's, yes, obvious, because the air has to deflect up as the surface is more faced to the wind. And so that shows you there. And sometimes you'll see some curly airflows, and you have to go back to your vehicle design and change that area so that you can get smooth flows. For now, it's just smooth and no problem. Okay, now we have the control surface right here. We didn't use it yet. I'm going to show you how to use it, the control surface. So I'm going to go to the aerodynamic analysis again. In the aerodynamic analysis, you add the control surface. You have from the control surface left and right, and pass them. You can add into there. And now you go back into the control surface angle can be given here. If you say give 30-degree angle on overview, 30-degree angle, which means the right aileron will deflect 30-degree up, and the left aileron will deflect 30-degree down. Or you can change that. If you go here, you can change the sign, the negative and positive. The negative, the pitch down, and pitch up for positive. You can do that. Now, for now, if you just leave it like that, normally what it calculates is one of the wing is up and the other wing is down. So you can see the roll and the other effects there. Or if you just want to see the pitch, make one of these negative so that both will pitch down or pitch up. Okay, for now, we have this. We add the control surface. So we go into here, we added the angle 30-degree, and we have the CG calculated already. Now, for the advanced part, I'm not going to tell you in detail, but what it does is it will calculate the stability and control of the aircraft. Now, for stability, there are different types of stabilities: the CD, the P, Q, and R. You can go and see by yourself. There is a documentation of OpenVSP for that. So let me go into the control and the overview, and then let me do the solver, and we'll see the distribution. Now you can see that it's not symmetric, as you can see, as compared to the previous one, because this aircraft is now rolling. The aircraft is rolling, there is a low lift distribution on this surface and higher lift distribution on the other one. And so that shows actually the rolling effect. And now it depends from which side you see, but it can be the roll right or roll left. But what you can see is just the distribution is not uniform and it's asymmetric. Now, as you can see here, the lift to the pitch is still negative. The slope is negative. That is fine. And we have the roll. Now, this one for the roll movement, you can see here. So you have it there. And actually, you can do your own analysis on this. The 30-degree gives you this much of distribution. Is that what you want or not? Is based on your own specific design objective. So you can play with the others like a drag and so on as it rolls, but mostly this is like a lift to drag ratio with angle of attack and the pitching and the roll movement and the others. The yaw is now because always the roll is combined with the yaw, so you get the yaw also there, which is unstable in this case. Okay, and also if you go into the soul and the viewer part, you can see that the distribution of the pressure on the surface is not uniform. More lift is on the right wing surface than the left wing surface. So it is like rolling towards the left. The aircraft roll towards the left. That is how you can see. Or you can change the angles, or you can change whatever you want in the parameters before the aerodynamic analysis, and you can see the trailing gauge. You see the airflows are not the same now because of this rolling effect, and you can see for different angle of attack how the air flows on the surface as they roll. I mean, as the aircraft rolls. Okay, now we're done with this, and the only thing I want to show you from here is how to import and export. Now you can go into file and then click on import, and so you can, I'm sorry, you can export this in different file formats. Like if you want to take this into CATIA, you can export it as IGS. That's what I normally use. And if you want to export it into ANSYS, you can, Blender, you can export it using OBJ. Let me just go with the OBJ for now. And I will save it somewhere in the file. And so image, and I have one OBJ there for the hybrid. I make sure I use that one. I can call this one test one. So it will add the extension by itself, so no problem. The OBJ is there. So one thing I didn't tell you is that it again says the shown part or all parts. I will just say the shown part only. So OBJ, and so you get test one, and that will go into where we want to save it, and you can cancel out this one. We don't need it, and you just click show. So the file name of your vehicle is here. We didn't name it yet, but we can save. You can save it. There is no name given to it. This is the default name, unnamed.vsv3. So you can save it. You can put anywhere you want. Normally in the folder of OpenVSV itself, and then anytime you want, you can launch it. And also you can import anything you want. Import any, like if you want to add the wheel or any component from external, you can bring it into here from any design. So you just click and bring the file of the format you want into here, and it will be added into the surface of the aircraft. And the other thing I didn't tell you is how we can add the background, which is very important. You can add the background, like click on here, background, and go to image, and then click on the file, and go into this, say, for example, what do I want to add? Say, okay, just the white one is not that much important. Let me say background itself. I click accept. Oh, I'm sorry, it screens out. Screen sharing has stopped. Oh, I'm sorry. Can you hear me? The screen sharing is stopped. Let me go back again. I'm sorry. There is something wrong with the design. Okay, I will go with. Okay, let me share it first. Okay. Okay, I hope you see it now. Let me go in. All right, okay, let me go into my file. My file, which I have been doing on yesterday, just for fun. Okay, I'm going to bring it that file. Okay, that file is here. A lot of things are there. I want to delete these old things. I don't want them. This is somehow intensive. So, okay, I have this design. This is the shaded part. And also I don't want this one. Okay, this is the blended wing type of UAV I designed for my own project. This is for agricultural purpose. We're gonna put the cameras beneath the aircraft and on the belly of the aircraft, and the wing is very long, and we have the tips designed this way so that we can avoid some airfoil air turbulence. So anyway, this is the design. I did the background. I'm going to bring the background, but I'm sure it will not crash again. I think the window crashed. That's why it makes me to be out of the Zoom. Let me try to bring any file. Let's say, oh, why not back? I just click on back and let me see. Oh, I'm sorry. Can you hear me? Let me.
Hello. Yeah. We can hear you.
Okay. I'm sorry. Let me do it again. There is something wrong with my computer. Okay. It crashes. I think the problem is with my own. It is nothing to do with yours. So let me try again. Okay, let me bring the window first. Let's say the background first, if I can. Right, okay, let me go into, say I have one background, say in D. Image. I did this before and I don't know why it crashed. Okay, I get the background. This is the fighter jet that I want to show you how we can use background. Now, let me just go back and show you again. Go into the window, background, and click on image, and then click on here. It will take you to wherever you want, and then bring the image you want. Now, in this case, we have the fighter jet. And now, there are, I think, three of them are there, but we don't have the back side. Now, if you want to design the fighter jet of this type somehow, you can use this one and just bring this as a background. Now, you can scale it also. I didn't show you that. You can scale it. The scaling is here. You can offset to X and also to Y as you want. Okay, for now it's okay. I'm going to just cancel this one and you will remain with that. Okay, I will bring the wing and so click add. By the way, you just select one of the components you want and then you have to click add to bring that into the window. Now we have this, so I'm going to design it. I'll cut it somehow maybe into sections, say different sections. So I will drag the mean somehow increases. I'm not going to show you everything, but I want to tell you that it's possible to do. Oh, exactly. It's possible to do the design after you finish this one. Like for example, you do all the drag, increase the span, go to this one, and all. Where is that section? And the root section increased. You can move this, the whole aircraft forward, but I mean into the tip, and then you can increase the length of your section, root section, say to 24. That is huge, and you can drag all the others into. Oh, where is that? That's it. Okay, and go into the other sections and do the same thing. Just fit into the structure. I'm not going to waste time on this. You can do it. You can finish up with the top view of the fighter jet, and then you can click on the side view, which is the side view, which is F7. You can go into view, and you can see that F7 is here. So the aircraft will give you the side view, because we have the side view of the fighter jet, and bring it that and go into the thickness and everything, and you can shape it that. For this part, we have to add another component that I didn't tell you. You can add another wing if you want. You can add another wing and just call this one to be like B1 or whatever. Okay, I call it B1, and then I have to add more wing, and so that I can bring this wing, only one section of this wing, cut the other section, and rotate this one about x-axis by say 90 degrees, and so you have it there. Now if I go to the side view, we have it here, so you can push back, and you can fix it right into the shape, and you can do that. After you finish, again, you go into the front view of your vehicle, and bring it into here. You scale it, no problem. You can scale it down, and so you can again match it in. If you have all this views of your background, and then you will get perfectly the design or the design copy of the background. That is one thing important, especially if you want to design the existing vehicle type. Okay, so we export it. We made export in the form of OBJ to Blender, and so I'm going to show you that in the Blender. So let me close from this, and I'm going to go into the Blender. Let me go into Blender. Right here I have a Blender. Okay. Blender is not a must. This is for interior design. We finished with the exterior design, but this is for interior design. Or maybe one thing I want to tell you that after you design your aircraft, for example, we'll see that in the next series, that you will take this aircraft into the flight control software, software in the loop simulation part, and you will use that, the designed vehicle, into that gazebo simulation environment, and do all the camera and everything mounted into the UAV or the aircraft. And then if you are interested to track some ground vehicle, you will see how it performs. All the sensors are provided by gazebo simulation environment itself, the virtual sensor, so you can do that. In that case, what you have to do is you cannot use the aircraft as it is. If you have a control surface here, you have to cut out the control surface from the UAV in the Blender. Cut out the control surface, because gazebo considers everything as a rigid body, and if you don't cut the control surface, it doesn't move in the simulation environment. So you have to take this one into Blender or CATIA and cut out the surfaces or any part that you want to cut out, or add any modification to the interior part, and so that you can use that in the simulation environment. The control surface will be rejoined to this aircraft in the gazebo simulation with some type of joints like revolve and hinge type of joints, and then you apply the force on the hinge. The simulation environment, I mean, simulation software itself will apply the forces on those control surface, and you'll see the deflection. And so, okay, now just a minute, I'll be back like 1 minute.
Hello? Hello? ዶክተር ይሰማል? ያንተ ድምፅ ዲስአፒር አድርጎብናል።
ሄሎ
ኦኬ፣ አሁን ይሰማል። ለተወሰነ ጊዜ ዲስአፒር አድርጎ ነበር ድምፅ። አሁን ተመልሷል።
ሶሪ እንትን ኬብሉ ላይ ችግር አለ መሰለኝ። ጊዜ አለኝ እንትን እንዳለ የተወሰነ ነው የሚሄደው። ከዚህ በኋላ ትንሽ ሰዓት ነው፣ ትንሽ ደቂቃ ነው።
እሺ እሺ ኦኬ
ሶ ብሌንደር ጋር ነው የምንሄደው። ሶ ብሌንደር ኢዝ ዲስ ዋን። ፋይል ውስጥ ገብተን ያንን ኢምፖርት እናደርጋለን። with that the obj file, we have an obj file, so we have to go into there. It is the file, and now image, I guess. Yes, we have it there. So we have different types actually. The my own, the hybrid type, and this one is the test one. We can go with the test one and see how it works. Okay, so I will import that. I will import this one. So import it. Just a minute. Okay, it is imported. It is imported, but it's a 90 degree to the surface. So let me rotate this one. I guess it's right there. Oh, there has to be rotation there. I'm not familiar with this much as such, with this thing. So yeah, it is there. So we can rotate it, say, or also right there we have a rotation, so we can rotate it the way we want. Just we can rotate it this way. But still I have to rotate. Okay. Okay, we have it. We have it there. Now I want to cut out the control surface. The control surface is right from here. So for that, we need an object to cut it. And let me add one object, which is say a cube. So I will take this cube and we scale it. Scaling is there. So let me just scale it. Okay, and then I will shift it into the surface I want. I want to cut it, cut the control surface using this, just a rough way of cutting the surface. So let me scale it again. So you can see how much of the surface has to be cut out from the aircraft. Right from the open VSV, the number is there, about 25% of the distance you can cut out, and the measurement is there. If you want, you can measure the distance, how much distance you need to take from right here into the surface. And actually you can take the whole length and then reduce the amount of control surface you want from there, and then you can put this box right there. Okay, so I'm going to cut out the control surface. Say that is a control surface, and so I'm going to cut that out. Okay, let me just give a little bit of surface. Okay, now I want to cut out of the surface in the Boolean. You just click on here and bring the object that cuts the surface. Take more time to take the control surface out, the copy of that, and later on we need it for the simulation in the loop part of our series. So anyway, we have this, so you can do any type of modifications. I mean, no modification, like views. If you want, you can see like this. You can smooth this thing, smooth it, and so you can see it here. Oh, fine. I mean, looks like a bird. Anyway, we can do that. We can do to the surface. This is not rough. I mean, this is not smooth cut because I did it randomly. The surface is not meshed well. In the open VSV, you have to do the meshing very well so that you can get the good cut. For now, I think it's enough. I did that for Blender. You can cut out, and also you can cut any part you want for, like, if you want the spoilers. Normally we don't do that for UAVs. Control surface are aileron and elevators, mostly the aileron, which combines aileron and elevator. We can deflect the both side of the control surfaces up to pitch the aircraft up or down, and that will use as elevators. So we can also use this control surface for rolling, and that's why we call it aileron, which is a combination of aileron and elevator. So that's it for Blender. You can do it, and after you did, to send it to Gazebo simulation environment, this has to be exported as .dae file. You go into here and go into the export, and actually it's not only DAE file, you can also use STL because Gazebo accepts STL file, and also the .dae file right there. You can click on here and export it as a .dae file, and we can use this UAV in our design. The other thing you can do with this is that if you want to make it more elegant, you can go into the text painter. You can paint on it. You can give different type of design on the UAV. It looks like more real, so that you can do that, and you can play with this. Different types of features are there in this Blender. So with that, you can export it. As I said, I don't need to export this one. And now, but you can click on here and export it to wherever you want. Okay, this is about Blender. I am not going to show you how to do this in CATIA. I guess I didn't download CATIA on here.
ይቅርታ Dr. Joseph.
Yeah.
I'm not sure ግን I think on the page line ያለ ነው. I don't know stuck ያድርግ Okay, we can see top view, front view, and
okay. Yeah.
crafting.
ድምፅ ይሰማል አይደለ?
ይሰማል።
All right. በቃ ከዛ ወጥቻለሁ ከብሌንደር ወጥቻለሁ። Now I want to show you
Okay.
yeah, I want to show you let me go into the okay, my file. I want to export the file. I think there is something wrong with this window. I can't see. All right, let me go into this one. My goodness, there is something wrong with it. I want to export my file in the form of STL or IGS so that I can take that into CATIA. But anyway, I think the second person who is going to present on tomorrow will talk about CATIA. The only thing I can say is from OpenVSP, you can go into the file type of IGS and you can save the file in that form, and then you can export that into CATIA and do the interior design as we did for Blender. So for the ANSYS also directly, you can take the STL of this, especially if you're satisfied with the conceptual and preliminary design of this thing. You want to get more advanced and refined result, you can export this into ANSYS. I'm not sure if I have ANSYS also. No, I don't have that. Anyway, the only thing I can say is I think Robert will talk about that. We'll talk about CATIA and ANSYS. I will ask him. But anyway, all we can do is then export this, whatever you design here, into different type of softwares like interior design normally, and then you can do more realistic aerodynamic analysis using commercial softwares like ANSYS. I think I finished here. If you have any question or suggestion, I will accept it. And thank you for listening.
ዶክተር ሁለት ጥያቄ
ኦኬ
ቻት ላይ ሁለት ጥያቄ አይ ቲንክ ጥያቄዎች የተነሱ አሉና just ask some of them. የመጀመሪያው ገድሉ how to select material type ይላል. So if you could elaborate on that.
Okay. እዚህ ጋር ኢቨን ቲክነሱ ራሱ ስንሰራ በኦፕንቪኤስፒ ላይ ኦፕንቪኤስፒ ቲክነስም ጀስት ሼል ቲክነስ አድርጎ ነው የሚቀበለው። እዚህ ጋር ቲን ሼል አድርጎ ነው የሚቀበለው። ኖርማሊ ማስ ምናምን ካልኩሌት የሚያደርገው በቮሊዩሙን የኤርክራፍቱን የእያንዳንዱን ኤርፎይል ቲክነስ ካልኩሌት እያደረገ የቮሊዩሙን አይቶ ከዛ ይሄንን ዴንሲቲ ወስዶ ነው። ኤግዛክትሊ ይሄን አይነት ማቴሪያል ብለን እዚህ ጋር አንሰጥም። ዴንሲቲውን ነው የምንሰጠው። ቮሊዩም አለ፣ ዴንሲቲ አለ። ይሄንን ተጠቅሞ ነው ማስ ጀነሬት የሚያደርገው፣ ኢነርሻል ፕሮፐርቲውን ጀነሬት የሚያደርገው። ግን ከዚህ ወስደን ወደ ካቲያ ከወሰን በኋላ ካቲያ ላይ ማቴሪያል ሰሌክት አድርገን ሞር ኢነርሻል ኢፌክቱን፣ ማሱን፣ ሲጂውን ምናምን ካልኩሌት ማድረግ ይቻላል። አይቻለሁ ካቲያ ላይ ብዙ ባይራራቅም የሚራራቀው ምናልባት ኢንቴሪየር ዲዛይን ውስጥ የምንጨማምራቸው ነገሮች ካላቸው የማስ ዲስትሪቢዩሽን ሲጂ ምናምን ይለያያል እንጂ በአብዛኛው ተመሳሳይ ነው የሚሆነው እና እዚህ ጋር ምንም አይነት ማቴሪያል ይሄን እንደዚህ አይነት ነው ብሎ አይገልጽም። ማስ ፕሮፐርቲ ምናምን እኛ ራሳችን ነው የምንሰጠው፣ ዴንሲቲውን ነው የሚሰጠን እና ከዛ ቲክነሱም ራሱ ነው አሳይን የሚያደርገው። ዋናው ነገር ይሄ የኤሮዳይናሚክ ሼፑን ብቻ ነው፣ ኤክስቴሪየር ሼፑን ብቻ ነው የሚሰጠን። ከዛ ኤር ፍሎውን ካልኩሌት ለማድረግ ነው። ይሄ ቤንድ ያደርጋል ምናምን ብሎ አያስብም ሶፍትዌሩ ማለት ነው። መልሼ ከሆነ በዚህ አበቃለሁ። ሌላ ጥያቄ አለ?
one more question ከዚሁ ጋር ተያይዞ how can we set the mass distribution across the wingspan and fuselage? So I think it's similar question, but
similar. No, again, one thing I would like to say is that you can add components. You can add components from here, and you can assign masses into it. You can assign masses into this, and then just it's not the realistic one, but you can put it and add, and you can put the mass into it. The length, the width, the height, everything is given there, so you can do that. And also there is one point, I'm not sure, they added something into it. I think the pod, or what is that, the blank, so that you can put some objects inside the aircraft to see the weight distribution inside. I'm not sure if this is a pod. No, there is no mass in it, but you can search by yourself, and you can get what type of box you have to, or object you have to put inside, so that you can get this is the conceptual and preliminary part of the design. So we don't care about that. We just care about the performance. But if you want the mass distribution again, you just put those objects, and based on the shape, on the volume and the length and so on, it will calculate the mass by itself. But still, the software is under development. Questions are concerning these areas, like how we can be realistic on the material type and so on and so on. But for now, this is, I think, enough to calculate things based on the density and the volume and so on. Okay.
Okay.
Any other question?
Yeah, one last question.
Yeah.
Yarit. It says, if we don't select material, how could we do finite element analysis using open software?
Oh yeah, okay. The finite element analysis, Mr. Rao, here in surface mesh ያደርጋል to small integrated panel mesh ያደርግና እዛ ላይ ነው distribution የሚሰራ። ይሄ አይዲያል ነው። በጣም አይዲያል የሆነ ሶልቨር ነው። ሶልቨሩን ብታዩት ቲዮሪውን ይሄ የኢንፋይናይት ዊንግ አይነት አሰምሽን ይወስዳል። እያንዳንዱ ሰርፌስ ላይም ካልኩሌት የሚያደርገው በጣም በብዙ አሰምሽን ነው። ኢቭን አንግል ኦፍ አታክ ዝም ብላችሁ ብትጨምሩ 20 30 ምናምን ብታደርጉ ሊፍቱ እየቀነሰ ይሄዳል እንጂ ስቶል ስፒዱን አይነግራችሁም የኤርክራፍቱን። ጀስት ካልኩሌት የሚያደርገው በሲምፕል በሆኑ ሶልቨሮች ነው። I think in detail እሱን ገብታችሁ ብታዩት ይሻላል፣ ብታነቡት ይሻላል tutorial parts. But still they are doing on solving the problems related to what you raised now. And I'm not sure about the detail of that. If I get more information on that, I may send it to you through Betty or the others who are working in the team. Any other question?
I think የጨረስን ይመስለኛል። በጣም እናመሰግናለን ዶክተር ጆሴፍ። በመጨረሻ ዶክተር ይሽሩን የኢንስቲትዩሽናችን ዴፒቲ ዳይሬክተር ጀነራል ፋይናል ማርክ ይሰጡንና እንጨርሳለን። ዶክተር ይሽሩን ይሰማል?
ይሰማል?
አዎ ይሰማል።
ጆሲ በጣም እናመሰግናለን። ዮሴፍ እናመሰግናለን። ያው ኢንፎርማሊ ኮሙኒኬት ያደረኩት ጓደኛዬ ነብይ ስላሰብኩ ነው። በአጠቃላይ ሁላችሁም ፓርቲሲፓንትስም ፕሬዘንተርስም ጊዜያችሁን ውድ የሆነውን ጊዜያችሁን ሰውታችሁ እዚህ ይሄንን ሴሚናር ስለተከታተላችሁ በጣም ነው ማመሰግነው። ስፔሻሊ እነ ዶክተር ዮሲ እና ሌሎች ድምጽ ኦኬ ልቀጥል?
አዎ
ኦኬ ስፔሻሊ እነ ዶክተር ዮሲ አሁን በዚህ ሰዓት እነሱ ጋር ሌሊት ነው፣ ወደ ከሌሊቱ 4 ሰዓት ምናምን አካባቢ ነው እና እንደዚህ ጊዜያችሁን ሰጣችሁ በተለይ ደግሞ ያው ከመሸ በኋላ እንደገና ካላችሁ ኮሚትመንት አንፃር በጣም ውድ የሆነ ጊዜያችሁን ሰጣችሁ እንደዚህ አይነት ኮሚትመንት በመውሰዳችሁ በጣም እናመሰግናለን። ሌሎችም በሚቀጥሉት ጊዜያት የሚቀጥሉ አሉ። ተስማምታችሁ በእንደዚህ አይነት ሁኔታ ስለተገናኘን እናመሰግናለን። ሌላው በተለይ ስፔሻሊ ማመስገን የምፈልገው የኤሮስፔስ ኢንጂነሪንግ ዲፓርትመንት ሄድ እና ስታፍ ይሄ ኢኒሺዬቲቭ ወስዳችሁ እዚህ ስላደረሳችሁ የምር በጣም ነው ማመሰግናችሁ። ከዛ በተረፈ ከኛ ተቋም ውጪ የሆናችሁ ፓርቲሲፓንትስ ስለተሳተፋችሁ እናመሰግናለን። ስፔሻሊ ይሄ ኮርስ ያው ብዙ ተደክሞበት ነው ጊዜያቸውን ሰውተው ጊዜያቸውን ስላችሁ አንደኛ የእንቅልፍ ጊዜያቸው ማለት የሥራ ጊዜያቸው ማለት ይሄንን ሰውተው ነው በዚህ ሰዓት የተገኙ ያሉት። በጣም ትልቅ ኮሚትመንት ነው። ስለዚህ ሌሎች ጓደኞቻችሁንም ኢንቫይት ብታደርጉና በጣም ሰፊ ማህበረሰብ የሚጠቀም ቢሆን ጥሩ ነው ብለን እናስባለን። ምክንያቱም የኢንቨስት የተደረገ ያለው በጣም ሰፊ ስለሆነ ማለት ነው። ከዛ በተረፈ ጥሩ ኢኒሺዬቲቭ ጀምረናል። ይሄን ኢኒሺዬቲቭ ማስቀጠል አለብን። ቲዮሬቲካሊ እንደዚህ ሀገር ውስጥ ከበር የሚያደርግ ብዙም ድፍረቱም ሁኔታዎችም አመቺ አይደሉም። ግን በእንደዚህ አይነት መንገድ ጀምረናል። የተሻለ ስራ ደግሞ መስራት እንችላለን። ይሄንን ያው ግራጁዌት ፕሮግራምም ጀምረናል ከአዲስ አበባ ሳይንስና ቴክኖሎጂ ዩኒቨርሲቲ ጋር። ስለዚህ ይሄ ተጠናክሮ ይቀጥላል ማለት ነው። ስለዚህ በእንደዚህ አይነት መንገድ እየቀጠልን እንሄዳለን። በሀገራችን የኤሮስፔስ ኢንዱስትሪን እናሰፋለን እና ያው ኤሮስፔስ እናለማለን። ያ ማለት ምን ማለት ነው? ኤሮስፔስ ሀገራችን ትልቁ የኢኮኖሚ ባክቦን እስኪሆን ድረስ መስራት አለብን። ምክንያቱም ሌሎች ሀገሮች በዚህ ዘርፍ ትልቅ ጠቀሜታ እያገኙ ስለሆነ ትልቅ ትርፋማ እየሆኑ ስለሆነ እኛ ደግሞ እዚህ ላይ ኢንቨስት ብናደርግ ኢኮኖሚያችንን ሊያሳድግ የሚችሉ ስራዎችን መስራት እንችላለን። እኛም ፕሮፌሽናሊ ማደግ እንችላለን። ከታች ያሉትንም ማምጣት እንችላለን። ስፔስ ማለት በሆነች በሳይንስ ብቻ የታጠረ ሳይሆን ቴክኖሎጂውን ሳይንሱንም ዲስከቨር ማድረግ የሚቻለው ቴክኖሎጂው ሲኖር ነው። ስለዚህ ቴክኖሎጂውን ማልማት ትልቅ ቅድሚያ ሊሰጥ የሚገባው ተግባር ስለሆነ ይሄንን አጠናክረን እንቀጥላለን። ያው ሳጠናቀው ሁላችሁንም እዚህ ጋር የተሳተፋችሁትን በጣም አመሰግናለሁ። ታንክ ዩ።
እሺ በጣም እናመሰግናለን ዶክተር ሽሉ። በድጋሚ ዶክተር ጆሴፍ እናመሰግናለን። ሌሎቻችሁንም እንግዲህ ከዚህ በኋላ ደግሞ በቀጣይነት እስከምንገናኝ በዚህ ላይ ጨርሰናል።